How are hashed passwords irreversible? Let's talk about it. If you're working with authentication that involves passwords, before you store those passwords in your database, there are two important things you want to do amongst many others. Firstly, you don't want to store that password as plain text. You should not store it as plain text. You want to transform that password to another bunch of characters. You call it decode the password, encrypt the password, or more commonly, hashing the password. And then that new generated string, you can store it in your database. But the second important thing is that generated string that you're storing in your database should not be reversible back to the original string. So in that case, you are making the generated string irreversible, and that's what you call a hash. When you hash a password, you're generating this irreversible bunch of characters. This is very important because in the case of a database leak, if attackers get access to the passwords of users, they cannot actually access the system because yes, they see the hash password, but they don't know what the original password was for the user. Of course, there are more complex ways they can figure it out, but at the basic level, you want to avoid that. Now, many years ago, I thought about this. How can you actually make a content hashed and irreversible? If there was an algorithm or a logic that transformed this string to this string, there definitely should be a way to transform the string back to the original string. But I didn't pursue this curiosity many years ago, so I never found out how. But this week I got curious again, and now I know how. And that's what I'll be sharing in this video. Now, if you want to jump to the section where I actually talk about how to make it irreversible, you can use the time code on the screen. But for now, I want to talk about what a reversible encryption looks like, or what I used to think hashing a password meant. So I have this simple function called reversible hash. What it does, it takes a password and then I loop through every character in the password. I get the character code, and when I get that character code, I add it to the hash. Now I have this thing called a separator here, so that when I am joining the character codes together, I have something that separates the generated code. So here, if we haven't gotten to the end of the password yet, I add this separator. Now this is a very simple transformation of the characters, but you can imagine that other encryption methods are more complex than this. So here I now hash my password, and let's log the hash and see what it looks like. So if I call node index, and then here we have this, let's call it the hash of our password, which definitely doesn't look like the original password or the original string we had here. But is this safe? Now this is not very safe, because if this gets exposed for a reason, and the attacker might notice a pattern here. If the attacker ever gets access to this logic, then we're done, because once they get access to this logic, they can then reverse the password. So here I have this function called reversible hash. So it takes the hash, then we get the part of the hash by splitting the hash into an array of strings. We're using this as the separator, and now for every character in that hash, we call string from char code, which is going to get the character for that code. Now if I come here and I try to reverse the hash, here is what we get. When I run this, we have exactly the same string that we used to generate the hash in the first place. If I change this to hello my dear $12 and I come here and run this again, we're able to reverse it back to hello my dear $12. In this case, we have a reversible hash, or let me call it an encryption. This is actually the idea of encryption, or decoding certain messages. It's a way where you can decode something or encrypt something. No, actually not decode, encode. It's a way where you can encode something or encrypt something, and you can be able to decrypt or decode something back. But in that case, it is reversible, but we don't want that with passwords, because this way, if a user gets access to this logic, or they are able to notice a pattern from a couple of passwords, they might be able to tell, this is how this hash was created. So how can we make this irreversible? Now let's look at an irreversible hash function. What are we doing here? Well, we have our hash string, then we loop on every character. Actually, this should be here. And for every character, we get the char code, which is what we're already doing in our reversible hash. But now instead of just adding that char code to the hash, here is what we do that makes it interesting. We do char code modulus 5, so we can get the remainder, and then we add that remainder to the hash. What makes this interesting? Well, if we come here now and we do password1 irreversible hash hello, and we log it here, here is what we're going to get. Oh, sorry, I keep running node test instead of node index. Okay, we get 41331. But what makes this irreversible is that, see this 41331, we can actually get this same hash with many other passwords. This hash is not just for the password hello. It can be for anything. When you come to this reversible hash that we had earlier, you cannot have two different strings generating the same hash. Why? Because two different strings have different characters, and different characters have different character codes, and it is the character codes that we add to the hash. So different strings would never produce the same hash. But when we come here, different strings can produce the same hash, because if you have a car code of, let's say 20 modulus 5 will give us 0. And if you have a car code of 40 modulus 5 would also give us 0. If you have 21 modulus 5 would give us 1. But that's not all. 31 will give us 1. 41 will give us 1. 51 would still give us 1. We have a sort of generic algorithm here. I don't think generic is the right word, but just hear me out. We have a sort of generic algorithm here which can apply to multiple numbers, which would give you the same value. And I can show you that. So here we're using car code. Now we do irreversible hash for hello. But if I do irreversible hash for MJQQT, we're going to get the same hash. Why? What I just did was, we have H produced 4. If I add 5 characters to H, that is IJKLM, we're still going to get 4. Same thing with E, FGHIJ, we're still going to get 1. With L, MNOPQ, that's why I have QQ and then T for O. We get the same hash here. We can actually try it out with another password. AI, do your thing. Oh, of course, AI wouldn't. So I call irreversible hash NOPQR KLMNO RSTUV UVWXY. When I run this and I call console log password 3 again, we have the same hash. This is why it's irreversible, because when you look at 41331 in the case of a database leak, you can't really attach this to any password, because this can either be for hello, or it can be for MJBQT, or it can be for Rovi, it can be for anything. And the fact that you have these many possibilities of original passwords for the hash is what makes it irreversible. You cannot trace it back. Even though the code, for example, gets exposed and you see that, oh, this is the logic that they are doing. Yeah, the fact that you know this doesn't tell you anything, because again, character code could be 40, it could be 50, it could be 60, it could be 70, it could be 80, and it would produce the same result. So the fact that this gets exposed doesn't really tell you much. I mean, of course, if they perform other complex ways, they can know what guesses. For example, what we have here is a very simple algorithm, car code modulus 5. So now they know, oh, we have to focus on this 5. We have to generate possibilities for this 5 that can give us 4. We have to generate possibilities of this 5 that can give us 1. Like, yes, there's still sort of a pattern, but then it takes the attacker more work to actually get the original string for a user. Basically, they have to get all the possibilities, hello, this, get so many possibilities and then apply them on each user. But this is not still the best algorithm, and that's why you have libraries like crypto, I think hashlib in Python. You have all of these libraries which perform a much more complex algorithm in the generation of the hash, but the same concept remains. The hash that is generated is irreversible in such a way that you cannot trace it back to the original password. Figuring this out this week, I was just so excited. I felt like, why didn't I realize this before? But I finally did. I thought to share. Hope you loved it. If you enjoyed this video, please give it a like, share, subscribe. I like to look behind the scenes and understand what's happening in the applications we use today, or in the languages, or in the code that we write. And sometimes discovering things like this are just so exciting. So I hope you enjoyed all my rambling. Well, see you in my next video.